Hi, in this video I'm looking at sketching the rational function y equals x over x take away 9. So we have a rational function here because I got two functions dividing each other. So that I can refer to these later, I'm going to call the top one p and the bottom one q, just so I can talk about them. So what we need to do to look at graphing this is we first want to look at asymptotes. So we have our two types, we got vertical and horizontal. Let's check out vertical first. And the vertical asymptotes come from when my denominator is 0, because that's what I'm trying to divide by 0. So if my q of x is equal to 0, which is x squared minus 9, is what I want to look for first. So that means that I've got 9 equals x squared, so x is going to be plus or minus the square root of 9, which is plus or minus 3. So I've got two vertical asymptotes, one where x equals 3 and one where x equals negative 3. I can then see if there's going to be any horizontal asymptotes, and they occur based on the interaction between these two functions. So I look at the degree of my two functions, so the degree of p and the degree of q. And the degree of p is, well, its highest power is a 1, and the degree of q, the highest power is a 2. And what I want to look at is whether they're the same, one's bigger than the other, or vice versa. So they're not the same, but p is less than q, so the degree of p is less than the degree of q. And that means that I have a horizontal asymptote at y equals 0. If it was the other way around, p was bigger than q, then I would have no horizontal asymptote, and if they were the same, then I would have to look at their coefficients. I can then go and have a look at x and y intercepts. So that would be my next thing to look at. So let's have a look at my y-intercept. So this is where x equals 0. So if I substitute x equals 0 into this function, I've got 0 divided by 0 take 9, which is just 0. So I have a y-intercept at 0. And if I have a look at the x-intercept, or zeros of this function, so these are also known as zeros, then that's when y equals 0. So I've got 0 equals x over x squared minus 9. Multiply the x squared minus 9 up to that 0, and I've got 0 equals x. So my 0 turns up at x equals 0. My y-intercept is at y equals 0, which means I have a point at the origin where they intercept both axes. So now that I've got my asymptotes and my intercepts, I can go and sketch my graph. So first let's draw up some axes. So let's have a look at my axes. So I've got my y-axis and I've got my x-axis, and let's quickly number this up. So now let's put in our information. So I had vertical asymptotes at x equals plus or minus 3. So on this graph, that means I got a vertical asymptote at x equals 3. So I'll put that on as a vertical dotted line at x equals negative 3, and one at x equals 3, if I can make it a little bit straighter. So another vertical asymptote at x equals 3. I had a horizontal asymptote, which was the x-axis, so I won't bother drawing that one on. We just got to remember that that's the x-axis. And then lastly, I've got my point at 0, 0, where my graph is going to pass through. So that's my x and my y-intercept. So now that I've got that information put on a set of axes, I can start having a look at what happens to my function around this 0 and my asymptotes. So let's have a look at first on the left-hand side. So this is everything below this asymptote. So this is when x is less than -3. And what I want to do is I want to look at when x is less than -3, what does p of x look like? And as far as positive and negative goes, and what does q of x look like? So if I look at p of x, which is just x, when it's less than -3, it's most definitely negative, so it's less than 0. And a q of x, when it's less than -3, well, that's going to be a big x squared number, minus off a little bit 9, so that's going to be positive. So that means that overall, my graph is going to be, well, I've got a negative divided positive, so overall my graph is going to be less than 0. So that means it's going to stay below my horizontal axis. So I also know that as I approach my vertical asymptote, my denominator is approaching 0, which means I'm overall approaching infinity because I'm trying to divide by 0. So I'm going to asymptote up to there. And that means I'm going to also have, as I get to much, much bigger negative numbers, that means that I'm going to be shooting off closer and closer to my horizontal asymptote. So my graph is going to curve and graph something like that. Perhaps a little bit neater. So that's a better curve. Have a graph that asymptotes like that. Okay, so now let's look at the next part of it, which is the bit here between my root and that asymptote. So this is when x is between -3 and 0. So I'll have a look at that down here. So when we're between -3 and 0, what does p of x look like? Well, it's still negative because it's just x and we've still got negative x values. What does q of x look like? So q of x is x squared take 9, so thinking about this, it means I'm going to be getting small x squared. So I'm going to be getting things between, well, if I had 0, I'm not allowed to use 0, but if I had 0, it would be 0, and if I had -3, it would be 9. So any numbers between 0 and 9 for my x squared, minusing off the 9 gives us numbers between 0 and -9, so it means it's going to be 0. Which means that overall, because I got negative divided negative, my graph is going to be positive. And as I approach my asymptote, I'm shooting off to infinity, because that means I'm dividing by 0, but I know I'm going to be positive. So that means I'm going to come down here. But I also know I'm going to pass through this 0 here. So I know that this is going to be a fixed point for me. And I'm going to curve up, hopefully a bit better than that, curve up towards that asymptote. Okay, we can now move on to my next part. So this is this gap from my 0 to my next asymptote. So between 0 and +3. So having a look at that, when we are between 0 and +3, my p of x, well, that's just x. P of x is just x, which means that because I'm a positive number, it's positive. Q of x, well, it's going to again be between 0 and -9 if I'm putting in numbers between 0 and 3, so it's going to be negative. So this part is going to be positive divided negative, means that this part of my graph is going to be negative. So it's going to mirror this curve here. So it's going to come down through there. And lastly, I can have a look at what happens after my final asymptote. So when x is greater than 3. So if I have a look at that, when x is greater than 3, p of x, well, that's just x, so it's positive because we're staying in positives. Q of x, what's going to happen with it? Well, it's going to be bigger and bigger x values, minusing off a tiny little 9. So we're going to also be positive, which means that overall my graph is positive divided positive, so I'm positive. And the same thing is going to happen where I'm going to be approaching this asymptote as I get closer and closer to 3, because I'm going to be dividing by 0, approaching infinity. And approaching this asymptote as x gets bigger and bigger. So I'm going to be sort of mirror image of this one. So I'm going to curve down like so. See if I can get it to mirror a bit better that first curve that I did. There we go. So that is the graph overall with this part, these two bits together, and this part. If I drew them all as one color as we should, would give me the graph of y equals x over x squared minus 9.